Hi, this is Ken Waters, and I'm the Warning Coordination Meteorologist from the National Weather Service Phoenix. Today I'd like to briefly introduce you to some new dust-related warning and advisory products that will be available soon. For many years, the only way we've been able to produce a dust storm warning has been to use the graphic hazard generator in GFE, which can create long-fused warning products under the non-precipitation warning category, or NPW. These were originally designed to address anticipated long duration events, such as a widespread several hour long dust storm. Dust storms in the desert southwest, however, are often short fused events that are convectively driven, often needing to be issued very quickly. In this way, dust storm warnings have more in common with tornado or severe thunderstorm warnings. Experience has uncovered several problems with the existing mechanism for producing dust storm warnings. First of all, it can be slow and cumbersome going through all the steps of working with the hazard grids, such as separating, merging, and publishing existing hazard grids. These dust storm warnings had to be included with long fused warnings, such as excessive heat warnings or wind advisories. This often led to a jumbled NPW product with confusing mixes of zones and valid times between the different products. In addition, the GHG uses public zones for specifying the geographic extent of the warning. Convective dust storms can form in different locations and move in ways inconsistent with these zone boundaries. And lastly, the recent development of the Wireless Emergency Alert System, or WEA, in 2012 led to another issue: dust storm warnings that have been upsized from public zones up to all affected counties for the purposes of these alerts, which often resulted in extreme overwarning, particularly in the case of very large counties, such as is common in the Southwest. This typically causes cell phones to sound the alert as much as 200 miles away from the actual threatened area, thus undermining the entire purpose of the WEA and prompting the public to want to turn them off. The final result is a warning that extends far beyond the threat area, is often delayed in getting produced, and results in a confusing product. This leads us to the new initiative, which will create two new products as shown on this diagram. On the left is the existing situation where we have dust storm warnings and blowing dust advisories. The right side of the diagram depicts the upcoming changes. Both of the existing alerts shown on the left are produced using GHG and are zone-based. The current dust storm warning may trigger the emergency alert system and will activate the wireless emergency alert cell phone alerts. With this change coming in the next few months, we will move to 4 different products. The dust storm warning will split into 2. The first will be a brand new Polygon-based dust storm warning produced by WarnGen. The other will be a blowing dust warning that will be long fused and zone based, just like the existing dust storm warnings. As for the advisories, the blowing dust advisory will also split into 2. One will be a Polygon based dust advisory and will account for convective situations where dust will be a factor but not reach the threshold of a warning. This will be produced in WarnGen as well. The other advisory will basically be the legacy blowing dust advisory with little change. The yellow boxes here indicate Polygon-based WarnGen-produced warnings or alerts, and the blue boxes indicate legacy long-fused dust alerts that will be produced with the GHG and use public zones to define geographic extent. This change will necessitate a brand new pill called DSW. Both of the WarnGen products will use this pill. The GHG produced alerts will continue to use the NPW pill with the warning now named blowing dust warning. The wireless emergency alerts will activate only upon the Polygon-based dust storm warning. Now onto the process of producing the new dust storm warning. This process will be very similar to how we produce tornado or severe thunderstorm warnings. Namely, we will use WarnGen to highlight the threat area with a polygon, and then send out the warning in the same manner. This animation shows the process using a looped outflow boundary. First, we invoke WarnGen, then drag to the target to the location of the threat area. You will have the option to choose a line of storms or a single point as you wish. This example uses a single point. Next step is to adjust the polygon as you wish, selecting the length of the warning from the drop-down, as well as the appropriate bullets and calls to action that are desired. Lastly, click on the Create Text button to bring up the warning product. Note that this specific example was done in Pumpkin mode and prior to having the WMO headers configured. These will be filled out in your office when your office is fully configured. Note the speed with which the new product can be produced, similar to a Tor or SVR warning. A dust advisory will be done in much the same fashion, using WarnGen for situations where the visibilities are not expected to be so low as to require a warning. Typically, this will be from 1/4 mile up to 1 mile. As you can see, the process is very much the same as with the dust storm warning. Lastly, the blowing dust warnings and blowing dust advisories will continue to be produced in GHG in the same manner. In this example, we first evaluate the threat using satellite imagery, and then switch our cave to the Graphic Forecast Editor, or GFE. All the same steps that we include separating hazards, creating a new hazard, merging them, publishing, and then running the formatter launcher using the baseline NPW formatter and enter the required text blocks. To conclude, these new warning changes will result in significant improvements in getting dust storm warnings out for those forecast offices that are impacted by these fast-paced, often convective-driven phenomenon. Warnings will go more quickly to cell phone users who are in the impacted areas only and reduce the overwarning effect for a better served public. This concludes this training session. Thank you for your interest.